Tonight's video links will be online on Moodle by Friday evening. I'm real busy the next few days, so it takes a real long time to upload them, like an hour for each segment. So let's finish our three-step proofs. We'll go through all the multiple-step proofs tonight, and then we'll look at some English translation. So word has it that we left off with, we did number 9. Number 10 is in the back of the book. So we'll go right to number 11. Somebody finds out that we did in fact do this, let me know quickly. All right, the first thing we want to do is look over our premises. Look over our premises and anticipate what they might be used for, and if possible, at the same time, what conclusion we could draw if we use them in a particular argument form. So for example, line 1 is a conjunction. It's the first thing you ought to notice about it. Conjunction is used in simplification. And so anytime we want to, we can extract the left-hand conjunct from that dot. We can have H horseshoe I right now if we wanted to, right? You also should identify that as a conjunction of two horseshoes, which is the first premise of constructive dilemma, right? Now, if you have that first premise of constructive dilemma, you know what the conclusion would be. It would be a disjunction of these consequents. In other words, I wedge K. This right here is what I call a setup. You need to be familiar enough with the rules to identify that almost immediately. So by setup, I mean that as they sit, those are the premises of one of our 9 rules of inference. So you find out which one, and let me know what it is. What's the name of the rule?
Disjunctive syllogism.
Disjunctive syllogism. So what would our conclusion be if we use those as premises for disjunctive syllogism? If we use these as the premises of disjunctive syllogism, what would our conclusion be? Yell it right out. H. Right? Verify that if you don't understand what we're talking about. Okay, so we can have H right now if we wanted to. We could have H horseshoe I. We could have H. We have everything we need to obtain those. Not saying we want them. And then, of course, let's see, what else is a wedge used for? It's used in constructive dilemma, right? Second premise. And then we have a curl. The curl is used in disjunctive syllogism, which we already identified. And it's also used in modus tollens. It's the second premise of modus tollens. I implore you to look over your premises and make all those identifications. You'll be way ahead of the game. It's not, you know, an idle exercise. It's a real important part of the procedure. But to begin the procedure, you know, we always ask, does the conclusion exist anywhere in my premises? If so, can I extract it? If it doesn't exist, then we know for a fact that the last step of the proof is going to be to create it. Well, I does exist. It exists in line 1. In line 1, it's the consequent of a horseshoe. Can we extract the consequent from a horseshoe?
Yes.
Yeah. Oh, you look at your extraction rules, right? And what rule extracts the consequent from a horseshoe? Modus ponens. Now, what would we need as a second premise for that modus ponens in this case? If our first premise is H horseshoe I, what do we need as a second premise for
H.
That's right, we need H. Hey, we said we could have H anytime we wanted, I think. See? But you can't just yank I out of that horseshoe because that horseshoe is part of a larger statement. So if that modus ponens is going to happen, H horseshoe I has to be brought out of the dot. But we already said that we could have that anytime we want. Okay, let's get started on our work. You want to use to figure out, or take a snapshot of the reasoning process. It's not absolutely necessary, but it sure does help, and you're welcome to it. We figure our last step has to be modus ponens, right? We said we would need as a second premise H. Well, we don't have either of those on a line by itself. So prior to that last step, two things have to happen. Good thing we have three steps, I guess, huh? We have to obtain H horseshoe I, and we have to obtain H. But we already know how to get both of those, don't we? Didn't we say at the very beginning we could have exactly those two statements anytime we want? Okay, go ahead and complete your work, and we'll have a look at it. While you're doing that, let me ask you this. Since we have everything we need to obtain H horseshoe I right now, and we have everything we need to obtain H right now, do you think it matters in what order you obtain it? That's right, it doesn't. How could it? Well, let's see. Just prior to this, personal preference, I'm going to obtain H. We said we could have that from line 2 and line 3 by disjunctive syllogism. Those two already exist. I'm going to make that my line 5. H horseshoe I, we said, that's coming out of line 1. Right? That's all we need, line 1. Simplification. So line 1 already exists. I'm going to make that my line 4. Those two will both exist when we get back to the future, ready to use them. All that work is done on your scratch paper for the test. You transfer the correct lines of proof to the test paper, in which this problem will appear like that. In cases like this, make sure you dump those parentheses or whatever punctuation. See, it becomes incorrect when you're extracting a punctuated component. So we said that's going to be 1. Then we want H, 2, 3. Then I. Questions about that proof? Any questions whatsoever? Now, these could have been obtained in the different order. In that case, your notation is going to change. Let's have a look at that. Let's say I prefer to get H first. And then H, horseshoe I. And then I. So have a look at that notation and either put it in your notebook or just compare it to what we just had to see how that changes depending on the order we draw these conclusions. Okay, so any questions about that group? That was pretty easy. Let's see what's up next. Okay, we have two setups there. Might not be as easy to identify as the last ones because the two of the premises are a bit more complex than they were in the last case. But you need to find for me the two pairs of premises that correspond to those in two of our argument forms, two of our rules of inference. Let me know when you find one. I'll give you a tip. 2 and 3 is one of them. What are we looking at there in 2 and 3? Premises of what rule? No. It's modus ponens. Everybody verify that those are the premises of modus ponens. If so, what would our conclusion be?
N horseshoe O.
N horseshoe O. So if we want N horseshoe O in this proof, we could have it any time we want, correct? Okay. Look at lines 1 and 3. Those are also ready to go as premises of one of our 9 rules. Find out which one. Disjunctive syllogism. So what else could we have anytime we want by disjunctive syllogism? M horseshoe N, right? Does everybody verify that? Okay, we all together then? All right. Aside from that, wedge is used in constructive dilemma. Horseshoe is used in many rules. Modus tollens, absorption, hypothetical syllogism. And the curl, well, that's only used in disjunctive syllogism and modus tollens. So again, look over your premises, make those identifications. It only takes a minute or so. It could save a lot of time later. Our conclusion, is that a question? Yes?
I'm going to ask, and it's probably going to sound stupid. Can you explain how you got multipolar? Right. You said 2 and 3, because you got curl.
They just have to be alike.
Well, what about a curl?
What can we substitute for a simple statement variable?
Anything.
Anything.
Okay.
So can you substitute curl L for P? Yeah. You remember the first day we went over those rules, I described them. I called them base descriptions. Okay? I said modus ponens has two premises. The first premise is a conditional statement, and the second premise is the antecedent of the first premise. It doesn't matter what these are. That's a conditional statement. This is the antecedent. That's a conditional statement. This is the antecedent. Good? Does our conclusion exist anywhere in our premises? No. So it has to be created. We know that for a fact. It has to be created, right? You tell me the two ways to create a horseshoe. What are they? Absorption and hypothetical syllogism. You must eliminate one of those from possibility because that conclusion, that horseshoe right there, is not complex enough to be a substitution of its conclusion. Which of those rules can we eliminate? Absorption. So now we know. I mean know what the last step of this proof is. It is hypothetical syllogism. So go ahead and start drawing up the argument you're going to use. I think you're going to stick a variable or two in there because we just don't know all the information about it. We know much, but not all of it. Right? You guys do that? Because that's the way to go. And go ahead and put my 6 in there because I know that's the last step of the proof. So how do you think this is going down? Do we have a horseshoe whose antecedent is M? Anywhere, do we?
Yeah.
Yeah. Do we have a horseshoe whose consequent is O?
Yep.
Yeah. And when we first looked over our premises, didn't we notice that we could have both of those anytime we want? So don't you think that's what's going to happen? Okay. Does it matter in what order you obtain them? What do you think about that? No, because we have everything we need to obtain M horseshoe O, M horseshoe N, and everything we need to obtain N horseshoe O. They were the two setups that we noticed at the beginning. All right, go ahead and complete your proof. I want to get this right before this for my own aesthetic reasons. So I'm going to make this line 5. Oops. Normally circle those. That'll be my 5. It'll be waiting for us. Then, let's see if I can squeeze this in here. Right? Do you have something like that? Yes? I'm going to make that my line 4. It'll be waiting for us when we get there. Questions about that proof? Are you all warmed up? Ready to roll on your own? I'll make a few comments. Maybe I'll just ask questions without pointing things out. All right, this then would be number lucky 13. Ooh, that's something we're going to become familiar with for the final right there. Look over your premises. Make a mental note of what argument forms they could be used in. You see every time that those things we notice, they're going to be used. Who has any ideas for the last step of this proof? You should have 2 ideas.
We're going to have to create it.
That's true.
And it's a wedge, so we're going to have to use CD or addition.
Constructive dilemma or addition, right? I'm going to let you work on this for a few moments. You know, I always say try addition first, unless you have constructive dilemma staring you in the face. If either addition requires, it will work, but it requires too many steps, then we know it must be constructive dilemma. And if addition simply cannot be done, then we know that it's constructive dilemma. But we don't have constructive dilemma staring us in the face. I know we have a conjunction of 2 horseshoes, but they're not the right ones for this conclusion. When you see addition, you can get addition to work. What do you think? Does it look promising? If you're considering addition, you should be considering how am I going to get Q, correct? All right, you tell me, how are you going to get Q? It exists in 2 places. Can you eliminate one of those almost immediately as a possibility? Which one?
Using simplification, the second part of the second conjunct.
This?
Right.
You're saying that
Simplification.
Q is coming out of here?
No, Q is coming out of the first.
Okay.
Line
Why,
one.
okay. Why is it not coming out of here?
Because we're going to be left with the other one after you do use simplification.
Well, for two reasons. If it could be got out of that horseshoe, first that horseshoe would have to be extracted from the dot. But we can't extract the right-hand conjunct from a dot. So that's all for that Q. There are two positive things about Q here. This is a left-hand conjunct of a dot. Certainly we could simplify it. And then Q is the consequent of a horseshoe. So you're probably thinking, after simplification, maybe I can extract Q by what rule? By modus ponens. Okay, so how many steps are we at now? Our last step is going to be, we think, addition.
Okay.
This is simplification. You have to get P in one step from someplace. What do you think? Well, P exists in three places. This is already ruled out because this can never be extracted from the dot. This is ruled out because it's the left-hand disjunct of a wedge. We cannot touch that. And this is ruled out. Oops, wait, I'm sorry. Q is P, I'm sorry, we're trying to get P, right? P is ruled out because this is the right-hand conjunct of a dot. Can't touch that. Yeah, P is ruled out here because it's the left-hand disjunct of a wedge. Can't touch that. And P is ruled out here because although we can simplify this, it's the antecedent of a horseshoe. Okay, so you're not going to get P. That means you're not going to get Q. And what does that mean for addition?
Use constructive dilemma.
That's right. Start drawing up your constructive dilemma. I've said this before, and it's real important. It's just as important to know what cannot be done as it is to know what can or should be done. See, because you waste a lot of time, spend a lot of time trying to accomplish something that can't be done. But if you're familiar enough with our rules and what can and cannot happen, cut short that avenue. And once you eliminate addition, now you're on the right track. You could be sure of that. It's constructive dilemma. So you know how we draw it up. You're going to be using some variables because we don't know everything about what that constructive dilemma has to look like. Did you draw it up? Should have done that. Yep. Did anybody do that? Well, that's what you should do. All right, so we have what I call partial premises. That means that there are some variables in there. We're not sure exactly what those components have to be. Whenever we find that we're going to use one of our rules of inference that has two premises, this is very often the case, and they're partial. And so what you have to do is look around to see what resembles either one of those. Now, this is pretty easy to draw to a close, because although we don't have a conjunction of two horseshoes whose consequents are Q and S, we do have two horseshoes whose consequents are Q and S. Right? So you could assume, I think, that those are them. They just have to be got together. Introduce them. You need to separate that one from its family and introduce it to that new friend right there. Go. And of course, we only have one disjunction. You could assume, well, see, that's got to be my second premise here. See? Let's go ahead and do that. Let's assume that, because it's only a three-step proof. We know this is the last step. We have one disjunction in the entire argument. It's a very safe assumption that that's the second premise of our constructive dilemma. And it exists. It's line 3. So you have two shots to get that conjunction together. How are we doing? Okay, well, it's obviously it's a dot that doesn't exist, right? There's only one way to make that. So you just have to ask yourself the right questions. It's not a question of I don't have any idea how to get this. It's how do I make a dot that doesn't exist?
Conjunction.
It's conjunction. There's only one way. And you always know what premises you need for conjunction. Right? 2 already exists. You just need P horseshoe Q to finish it off. How are you going to get that? Simplification. Are we done? So that already exists. We're going to make this line 4. It'll be there waiting for us. This will be line 5. That'll be waiting for us when we get there. Make sure you drop those parentheses in this case. Absolutely incorrect. What are we looking at? 4-2? Oops. Good. All right, one more, and then it'll be break time. 15's in the back of your book. Don't neglect it. This will be then number 14. I need to make my board work neater for those folks at home. Right, you should be thinking simplification and construct a dilemma, and also what would the conclusions be in either case. You should be thinking simplification or construct